Cole will be talking through some of the ideas of the digital fabrication revolution and 3D printing. So you can introduce that. Okay. Little background on Cole. Cole fabricates custom-made and small batch home furnishings utilizing a combination of advanced manufacturing technologies and traditional crafts techniques. He has worked with computer-aided modeling software for over a decade and 3D printers for over 5 years. A native of Philadelphia, Mr. Hastings is current owner of Cole Hastings Jewelry and Furnishings, a design company in Scranton. And he's also an adjunct professor at Johnson College. Cole, take over.
Thank you very much. Hello everyone. Today I'll be talking briefly about 3D printing and digital fabrication as it pertains to the educational landscape and the student-teacher dynamic. I wanted to start off by saying welcome, and I have a BFA in crafts, one of the rare degrees nowadays. It's from Kutztown University, where I specialize in furniture design. I also have I recently got my master's in fine arts, specializing in studio art from the Maine College of Art. I wanted to start off by a quote that I think is very relevant to the rest of this talk. You can't just give someone a creative injection. You have to create an environment for curiosity and a way to encourage people and get the best out of them. It was said by Ken Robinson, who, if you haven't seen any of his TED Talks about the education and changing paradigms, it's something I would really stress for you as anybody who might be a teacher or an instructor in some level. He is an advocate for constantly trying to reevaluate how we deal with education, especially when it pertains to creativity. I've seen firsthand what can be done when creativity is truly encouraged. Teaching philosophies need to change and adapt to the new students that we're seeing. 3D printing is an almost boundless fabrication method that is getting more and more diverse. Teachers need to adapt alongside the same manner. We see a lot of stagnant teaching methods still in use today, such as like the lecture platform, kind of like what I'm doing right now, where I just kind of talk at you and you hopefully will retain some of that information. With 3D printing, I think as this progresses, you'll see that we can really change that dynamic and create a more engaging atmosphere where people can learn more. Not just the student, but also the teacher will grow as well. So I've been on both sides of this conversation. As a student, I started off 3D printing in my apartment when I was a senior at Kutztown University. My school had just got a 3D printer, and the professor of 3D modeling and furniture design was in charge of that printer. We were both learning how to use the printer at the same time, and we were using almost the exact same model printer. We were both using a MakerBot, early models. And I had a background in robotics where he didn't. So I kind of had this leg up when I was learning how to use it versus when he was learning how to use it. Quickly, I outpaced him, and I realized that he was not adapting to the environment quickly enough. It created a void in our student-teacher relationship. We weren't working together. We were actually working against each other in a lot of ways. I would see problems that he's having that I've already figured out how to fix, and he was not really curious about how I came up with those fixes yet. He kind of just wanted to learn on his own. And I think that there was something in that whole kind of hierarchical structure that happens with the student-teacher relationship that I think was at a problem there, because I could have learned things that he's fixed at that point, and he could have learned things that I fixed, and we could have actually advanced each other a lot faster, but that relationship wasn't forming. There was also a gap forming between me and the school as a whole. None of the instructors knew how to 3D print, understood what could be 3D printed, and they couldn't critique it because they had no idea how to categorize it. After all, I wasn't a crafts program. There was furniture and woodworking, ceramics, fibers, and jewelry. All those programs could use 3D printing in different ways. Just none of them were open to doing it just yet. Fast forward several years, and I'm teaching now. My students have heard about 3D printing, but never seen it in person. They were curious about the images I was showing them about this new fabrication method. I was framing it in an art context, since art encompasses so much. I decided to take some time in class to bring in a variety of 3D printed objects. They were just so curious about everything. They could touch the pieces and see the layers. All of a sudden, the whole process made sense to them. I knew that I had them hooked, and I could use this as a topic to branch out to all sorts of new information. After all, everybody seems to be using 3D printing these days, and it's in the news more and more. The students were excuse me. The students are changing in this new technologically driven world. Access to technology is astounding. It seems that every student has a tablet, laptop, or smartphone, or some combination thereof. They also like to use them in class a lot. I'm sure you've all experienced this. But what if this access to new technology could be used as a learning tool? Just a thought for the future. What if we could access this and use their own technology that they're bringing into class to maybe utilize some sort of 3D printing or morphing type of applications like the Morphe app. These students who couldn't sit still are being inundated with media. There are so many sources such as social media, notifications from friends and news apps. They're used to doing homework at home with music or TV on in the background. They have several windows up on their computers with Facebook and Twitter going on simultaneously while they're trying to do their work. For a lot of us, that's pretty intense information overload. And for them, for these kids coming up into the schools, this is just secondhand to them. They're used to this type of behavior. They're used to flipping back and forth, multitasking on their smartphones, as well as reading books and listening to music and involved in a conversation. We also have a lot of kids that are not used to the traditional lecture class, or they're not getting the most out of it. These students are the ones that are typically known as visual and tactile learners. They're a group that is most often left in the dust as students. We're usually categorize these as good with their hands students, students that are more practical application than actually theoretical. And this is where 3D printing can actually come in. 3D printing can level the playing ground for these students. Putting out a part for the lesson, getting it out of the textbook is a huge educational tool that's just getting started to be used. Every classroom can use 3D printing. Some people will actually point out that classrooms that they just can't see being used, and I say you're not being creative enough. I actually challenge teachers to be creative when it comes to this stuff. For instance, one of the things that could be said is, well, how would 3D printing apply to an English classroom? You're reading out of a book, or you're trying to understand something that's very abstract. What if you printed a copy of Achilles' shield out of the Iliad from the description, and let kids actually understand why there's a 3+ page description on this one item? It could really change the effect of that book for someone. It could change the effect of learning about history and paintings if they could actually see them in real life or touch them. A lot of the new technology they're using is taking paintings and creating proportional topographies to them, so blind children can actually, or blind people in general, can actually feel the painting. And then all of a sudden, now there's this new transition of a group of people that have never been able to experience a type of artwork or a type of object fabrication are now learning and feeling and touching these things and understanding them in a different level. Something that's very culturally relevant. Architecture students, I'm sorry, getting ahead of myself here. 3D printing applies to all the disciplines of the educational landscape. Medical architecture and design and transportation technologies, just to name a few. For instance, medical students can study at full scale organs and bones. Printing out deformities in natural biological structures creates an understanding of how these systems work. It is far more encompassing to the students than just pictures in a book. The student can actually touch a bone or understand why it should feel the way it feels. So when they feel a broken bone in real life after they've been through medical training, they'll identify why it's wrong, and they'll be able to help with that trauma a lot quicker, getting the person out of that risk category a lot faster. The image I have up there, that 3D printed heart, was actually done of a boy in Austin, Texas. When they actually 3D printed his heart and they were able to slice it into 3 pieces, the surgeons were able to look at what was wrong and the deformities in his heart and be able to go in and do a lot faster surgery for him. So you can see how 3D printing would apply directly to medical technologies and medical students. This is architecture students can take 3D designs and bring them in the real space, no longer virtually walking around a house to fully understand it. Design students can realize designs that would be more complex or time-consuming for traditional manufacturing methods. The image you see here is a woman sitting in front of full-scale 3D printed columns. These are structures that would be almost impossible to build in a traditional method. But the way that this artist was able to make sections and then be able to stack them and create a full-scale architecture is pretty awe-inspiring. And lastly, transportation technology teachers can 3D print various mechanical problems for students to fully understand what is wrong, enabling them to fully grasp how to fix complex engines and transmissions. The students will be able to see how all sides of the parts, just like the engine block, in ways that they would never be able to with a full-scale object. They can see the engineering involved. And maybe, just maybe, like, this is a way that students can grasp a way of engineering or seeing the engineering, that they'll be able to come up with solutions and parts and problems and designs that could revolutionize this world. You know, we looked at the earlier keynote address, and he talked about redesigning that one piece on an airplane and how much you can actually get out of that. Well, that's the future of student design. That's the future of engineering design, is to see those types of things, to work with those new ways of engineering. With these new approaches, maybe students and teachers can work together to create new designs and new ways of fixing problems that we once had. If you take nothing away from this talk, I want you to think about this. The connection between technology, teacher, and student can be propelled into new levels and use in 3D printing. Students and teachers can come together for new innovative ways, new approaches to problems together. The teacher-student relationship dynamic can and will change. Remember, technology is what propels human culture and understanding. No matter if it's the fire or additive manufacturing, technology is what we're all about. And that's what I really want to leave you with. I want you to think about this from a theoretical standpoint as well as a practical. We've had a lot of conversation about practical uses and the actual technology involved in 3D printing. But I want you to think about the theoretical application, the application of how teachers will deal with this, and how students who are going to grow up with this, with those $200 and $500 printers that they might be getting for Christmas or on their birthday, because they're really interested in these things, they will evolve and they will come up to your high schools and your colleges, and all of a sudden they're going to really have a good grasp of the basics, and they're not going to need that 101 class, and you're going to have to adapt to that. But that's a good thing. That's the kids that you're not going to have to worry about, but the kids that will help you out with becoming a better program. With that, I wanted to say thank you, and I am open for questions. Questions? Come on, nothing.
Mine's more so a statement. Great presentation, by the way. Being a student myself, I definitely like that whole paradigm shift of the professors kind of going into the direction of what us as students are really exposed to with social media, with 3D printing and technology being ever-changing. You know, we're surrounded as students by a lot of great minds with regard to the professors, and at times they don't want it to change because people would rather die than change. So, what a great presentation.
Yeah, I mean, when I did some graduate work at Indiana University of Pennsylvania in the woodworking department, and I was able to teach in the advanced woodworking department classes, and I found that it was really interesting that when students were like, hey, I want to make this bandsaw box because that was a project, and they wanted to make a more three-dimensional form that would just be just a straight cut and some glue up, the teachers were like, no, you don't want to get involved with that. It's going to be too complicated. And it was just like, you're just slamming down an idea right off the bat. Why not see if the student can come up to that level? Especially since failure you can learn from so much more sometimes than actually succeeding. You know, some of the best critiques I've ever sat through have been the ones where someone has failed, like utterly failed, and like they're just like, this is what I learned. And that's what you should take away from it, is that like all of a sudden you've learned something. And I mean, what was it? How many light bulbs designs did Edison go through before he hit that one? And that's like the important one. I mean, 3D printing allows iteration to a completely insane level. And so I think that acceptance of failure, the acceptance of students and teachers working together, rather than kind of, I know this and you don't, and you're gonna learn from me and you're gonna learn in the same way I work, I think is a destructive path. You know, some of the best things I've ever learned has been from when I've been teaching and something a student would say. So, thank you. Anybody else?
What energizes you the most about this technology in the future?
It's boundless. It really is. Just because we're not doing it right this moment, or we're not using the technology in a certain way at this moment, doesn't mean it won't be used in a completely different way in the next 5 years. One of the things that also is something that I love about this is, as a traditionally trained woodworker who has arthritis in their right hand at the age of 30, I know that I have a ticking time bomb, that at some point I will not be able to make the way I was trained to make. And this is a technology that completely eradicates that need. But it uses all that training to in how objects are formed, what's aesthetically pleasant, what proportions look like, and how those things work together. I can use that knowledge still, even though I might not be able to use my hand in so many years. So there's like that aspect of like, anyone can do it. You know, I could be in a wheelchair and be building tables. I could be, you know, lay down in a bed and building buildings eventually. And I think that that's something that's all inspiring to me.
Cole, thank you very much. Appreciate it.